the overall strategy of a release for SQL. For me, it's especially special. This being the 25th anniversary of SQL Server on Windows. This is the 16th, yeah, there you go. And for me, it's especially special because 2 weeks ago, I was able to have my 25th anniversary here at the company. So pretty special for me. 16th release for me for SQL Server. Anybody? This is the 16th release? Anybody? Oh, darn. Oh, okay, we can feel old together. Thank you. So, oh, good. Here we go. 16th release. Love it. Thank you. So, hey, it's very exciting to me to be here today. My partner in crime, Amit Banerjee, and I did this session at Ignite, and I'm amazed that he agreed to do this again because I'm full of hot air and I usually take most of the time up. So, Amit, why don't you tell you a little about yourself? Everybody knows who you are.
Thank you, Bob. Good morning, everyone. Welcome to the session. It's a privilege to be presenting with Bob. I work for the SQL Server engineering team, and I lead program management for a team called the MS SQL Tiger. Some of you might know that. And this is going to be a power-packed session. There are going to be some new announcements, and we're really looking forward to going through this journey from what we have in public preview today all the way to the general availability for SQL Server 2019.
Yeah, as Amit said, it's called a roadmap session, but hey, when we had to publish this session, we didn't quite know when SQL 19 was going to launch, so I couldn't really say that back then. But that's really the focus of today's session. It's about SQL Server 2019. It's about our strategy, but it is a roadmap session. So at the very end, we will definitely be talking a little bit about what's past this, what is going on past 19. So in order to achieve that goal, Amit and I did something interesting. We went to our boss and said, would you come with us on stage and talk about this because you're a big part of establishing the strategy for SQL Server and SQL Server 2019. So with that, I am proud to introduce our manager, Asad Khan, who is going to talk a little bit about 19 overall strategy, kind of get into a little bit the big data cluster scenario, and then Amit and I will actually do some more past that, and then Asad will kind of close our day out. So Asad, let me turn it over to you.
Thank you, Bob. This is very nice of Bob. Otherwise, the way it actually happened was that I said, Bob, like, how do I get crowd in the room and a good rating? And he said, man, just write your name with my session and you will get both of these things. So hi, I am Asad Khan. And I actually joined SQL Server around the time when we were shipping 2017. So very different than the history Bob has. And since then, it has been an amazing journey. Both very exciting and humbling. It has been exciting because I get to work on one of the most successful products in Microsoft. Which has a huge penetration in the market, and man, it makes a lot of money for us. So really exciting and humbling because every day I get to work with people like Bob and Connor and Slava and the community, and I get to actually see how this product was shaped and had a huge impact in the market because of this close collaboration. I think if you go and look at like even this conference itself, it's a huge testimonial of like basically how the community and the product teams have come together. So again, really privileged to be here with you and like look forward to for many years to be working with this community. Thank you very much. So the plan was like, again, this is as we go into the details, like the idea was that you have seen this slide in the morning in Rohan's keynote, and my plan was to cover a little bit of like why we decided to do that and what is the background story in terms of like why we are going in the direction we are going. Because like in terms of what is the actual feature and things like that, I'm sure you will get to see in the demos, in the blogs we put out, and of course when the product is out, you can get to use it. So if you look on the left side, starting from that, I will go towards the right. The first thing is like which is the intelligence over any data. So my background, like again, at Microsoft for last 3 years before joining SQL, I was actually running big data team in Microsoft. And when I joined the team, like the discussions we were having were very interesting because I was coming from a different world. And when we go and used to interact with the customers, they were looking at a very different problem, which is like, oh, how do I go and look at my unstructured data? How do I set up my clusters? And what we realized is that the ecosystems which are being built for the big data and the ecosystem which has been developed for the relational stores has not only diverged, but even diverging even more, both in terms of how the tools are set up, how the people who use those, the skill sets they have. And the problem that it creates is that in the end, the companies are trying to solve the same problem, which is like, I want to go and analyze all my data. I want to go and build intelligent applications. I want to go and bring insights from my data. And now if you go and create two different ecosystems, one which is very much focused around OLTP, RDBMS system, and one which is focused very much on the big data and machine learning and AI, like you have a problem when you want to go and merge those things. And like many times we will go in the companies and many times, like actually often we go into the companies, even the departments who are doing big data and relational to different departments, you go and talk. So the vision we had is that how can we go and bring them together? So that was one thing. The second thing was that if you go in the big data world, there has been a constant innovation, which is like, how can now I have solved the problem of dealing unstructured or querying unstructured data. How can I be a little more around the transactional capabilities or faster queries? If you go and look on the relational side, people have been like, now I have solved all those problems in the last 2 decades. How can I go and do big data? Which is totally fine. But there are cases where like you can make it easy by solving the problem by saying, why can't I bring both of them together? So that was the vision we had, which is like, OK, I think we have the capability where we can bring the best of the big data and the open source and the best of the SQL in a unified platform. And that will ease the work that the customers have to go and do to set up the clusters, do the security, have a single tool that can go and span both systems. So that's the goal we have with SQL 2019. The second one, which is the choice of the platform, actually there is a lot of, in a sense, the information which is condensed in that one column. That has 3 dimensions. One is the choice of the platform. And again, like the one thing which we did in 2017 was bringing Linux. And that was a huge step forward for us, both in terms of like it just make it easy from the customer point of view, because now they have the choice which OS they want to run. But from the commercial point of view, it just opens up new markets for us. So that was a phenomenal step forward. And if you look back now, like it wasn't like it wasn't some secret thing, like we should have been on Linux. The problem was technically it is very, very hard. Like how can you take SQL, which has been innovating for the last 20 years, and suddenly bring it on a new OS? And this one purely happened because of the engineering marvel of how basically the team was able to build a SQL abstraction on top of the Linux and keep the same code on, running, which runs on the Windows. So that was one. The second dimension is about the languages. Like again, new scenarios are coming every year in terms of how you do machine learning, how can you go and use libraries which has been developed by data scientists over many years. And that's where we started the journey in 2016 with the support of R and then later on Python. And now we bring Java. But the important thing is like the way we brought Java is the language extensibility, which means think of it as bringing Java as an example. Now, an ISV, a customer can go and use that extensibility to support any other language they want in SQL Server. The third dimension on this one is the whole containers and Kubernetes. That itself is such a big topic that basically we can spend dedicated sessions, and we have those sessions I would encourage you to see, because that totally changes the game. Like basically, if you go and look out there, containers plus Kubernetes on how people are managing that is totally changing the industry out there. It is creating a new abstraction layer where you can run your stateful and stateless applications. And when the time comes in terms of how do I set up my own private data center or how do I do a lift and shift, it becomes totally a different way on how people are thinking about those problems. So that is the goal we have with the second pillar. The third and the fourth one are about, like, in the end, like, we have to make sure that we follow the technology trends and we go and evolve. But in the end, we need to take care of the customers who pay us the money. These are our loyal customers who every day use SQL Server in their mission-critical OLTP scenarios and other scenarios that is currently offered by SQL Server. So this is the area where you will see the innovations we go and talk about, adaptive query, or taking advantage of the hardware innovations that we are doing through PMAM and other technologies. And similarly, on the security side, if you go and look at it, the hardware enclave for data encryption, and the GDPR support we have for tagging that spans all the way, where you can tag a column all the way into the application. The last one is about the unification. Like basically, one of the key reasons SQL has been very successful is that you just buy SQL Server and you get everything part of that. And BI has been a huge pillar in that regard. And we actually used the same theme when we brought the big data, because the initial discussion is like, OK, is it a separate thing? Should we bring big data in SQL as a separate thing than in SQL? No, like basically, we need to go and keep the same rhythm out there, which is like, if you are buying SQL, you get everything. And it is the same tools. It is the same security model. It is the same bundling that customer has to go and buy. So this is pretty much the vision we have with SQL 2019. A lot of these features have already landed as part of the CTP that we released in Ignite. There's a new CTP going out this week, which is the 2.1. And hopefully, we will continue to go and innovate more with newer features, and then release SQL as the brand says it in 2019. This one talks about more in terms of what is the ambition we have with SQL 2019. Some of it I already covered. Again, like basically, as I said, like we want to make sure that we can go and deal against all type of data which is currently lives both on-prem and in the cloud. So basically, how can we use SQL Server to manage all enterprise data? And of course, like there's a limit to what you can go and fit in there. I'm sure people have legacy system, or people have other reasons where people have data sitting in other databases or in NoSQL store. So basically, it's a combination of like you can do unstructured and structured data in SQL, but you can also do data virtualization and reason over any data that is sitting in Oracle and Teradata and MongoDB, and all those capabilities are included in SQL 2019. Then again, from the manageability perspective, we have a very hard principle in terms of like we will go to extreme in terms of solving the hardest problems in terms of how do you do authentication, how do you do authorization, and these things are very, very different in SQL Server and big data systems out there. But we want to go and unify that. And basically, we want to have single experience. That's why we are pushing hard for Azure Data Studio, so that people have the same SQL tool, and they can use that for data virtualization, they can use for big data, they can use for ML, AI, and that's why you see innovations like we bring in notebooks in there, flexible visualizations in there, and the full ML capability all integrated in the same tool. And the last one is analyzing data, and again, that is enabled because of the work that we do in integrating the data and the managing the data, which helps you analyze all the data irrespective of where and in which format it is sitting out there. This one is like, I will go quick on this one because this is more like Amit will go in deeper on this one. This is more in terms of like, I spend more of the time in terms of what we are trying to solve, and this talks about like how are we trying to solve. Like I talk about like how we bring big data, why did we choose Spark, and what capabilities Spark brings in. Or we are doing virtualization, how are we even doing it from the technology perspective. Now I will hand over to Amit to go and go deeper on some of those things. Thank you.
Thank you, Asad. So as Asad was saying, we're actually changing how you think about your data. It's just not relational data anymore. It's not about unstructured or semi-structured, it's just data. And if you have data that you need your business to use and to gain insights, it is available within SQL Server today. And these are the three pillars that Asad talked about, and this is how the actual architecture looks like. So if you look at data virtualization, if your data is residing in any other platform, whether it is a SQL Server instance that's running, let's say 2016 or 2017, or it's another relational platform like Oracle, or if it's a NoSQL store, or even another HDFS store, our Polybase connectors can connect to it and make that table part of your SQL Server database. So you can actually do a select star on a table or an object that is not even in SQL Server, and a user would think that they're just querying the SQL database. So if you're familiar with T-SQL, and if you develop against a SQL Server database, this is just seamless to you. You can apply the same security principles. You can apply the same high availability and disaster recovery capabilities, and it just looks and feels like SQL Server. The next part is the big data integration that we're providing with SQL Server. So SQL Server now will not just have your database, it will also have a HDFS store that can store any Hadoop data, and it can directly write into that HDFS store and query it with T-SQL. So you can actually do a select star from a Hive table. Let's say the Hive table is named orders. You can actually do a select star from hive.orders against that table. And what that gives you the capability is you can take that table and write an inner join with the table that's residing in another SQL Server database. So you can actually do, and this is where you need to pause and think about it a little more. You can do a select star on hive.orders and do an inner join on a SQL Server customer data table, which is residing inside a structured store. So that capability opens up, and SQL will also allow you to do queries over your HDFS data sources using Spark. Because we're shipping Apache Spark with the SQL Server cluster, you would be able to make a Spark query or submit a Spark job to SQL Server, and that just looks and feels as if you're operating within the SQL Server that you're used to today. And lastly, we announced SQL Server machine learning services in SQL Server 2016. In 2017, we added Python. And as part of that journey, now that we have Spark, you'll be able to use the machine learning capabilities that Spark has, and you'd be able to do all sorts of ML scenarios. If you're a Spark user, you can do it on Spark. If you're a SQL Server user and more familiar with running R and Python scripts using T-SQL, you could use that as well. So for those who are of the more technical mindset, let me just blow your minds and show you what the cluster looks like. So the first thing is the storage. As I said, we'd be shipping the HDFS storage with SQL Server. So if you install a SQL Server on a Kubernetes cluster, you'd be able to get the HDFS store, and that's what the storage spool looks like. Each of the Kubernetes pod will have a HDFS data node with the Spark and the SQL Server runtime running on it so that you can query it. You can actually query it really fast because you're actually storing data which is closer to your compute, and you can partition your queries across your data nodes, which makes data retrieval really fast. The second part is if you're running a query, that's the compute pool. You can use the SQL Server runtime to query over your HDFS data, and you can actually do a distributed query across your data nodes. And that's just not it. If you're pulling data from an external data source, you can create that and cache that data inside SQL Server in a data mart, which is backed by a column store indexes. And all of that put together comes in the big rectangle that you see on your screen, which says the cluster. That is one SQL Server instance, which can elastically scale out and scale back in as you need. So if you need more compute to run a heavy compute-intensive job, you can scale out your cluster, finish the job, and scale it back. That's the goal for what we have for SQL Server 2019. And all of this comes as one cluster, so you can actually use Azure Data Studio to manage your SQL Server instance as if it were just one single entity. Now let me switch over and show you what a unified data hub would actually look like on SQL Server 2019. So let me just switch over to my remote desktop. So what you see here is an Oracle database where I'm actually storing some loan information. So these are vehicle loans that are stored. And 2 years ago at Ignite, we'd actually shown a demo where we could actually take vehicle loans stored in a SQL Server database, and we were scoring those loans at 1 million predictions per second. And the predictions were about whether the loans would get charged off, whether they were bad loans or not, and whether the bank that was issuing those loans needed to take some action. But in this case, it's slightly different. The loans are actually sitting inside an Oracle database. And what I'm going to do is I'm going to connect to my SQL Server 2019 instance with Azure Data Studio. And I have this database called past loans. And I'm going to create this external table. And what this external table does, the wizard does, is it shows you an option. I'm going to choose Oracle here. And I have a master key, which is already created, so I don't need to create it again. It's going to ask me for a name. So I'm going to give it the name Oracle. It's going to ask me for the source. Then it's going to ask me for the database name. I already have a credential, which is created. So this allows you to maintain the security without having to divulge any username and password because this is stored as a credential in SQL Server. And when I click on Next, what it gives me the option to look at is all the tables that are stored inside my Oracle database. And in this case, I'm going to pick the vehicle loans and the branch information sitting there. Now, once I do that, it gives me the option of creating a SQL Server table, which is named dbo.branch and dbo.vehicle loans. And this will create an external table which I can select from within SQL Server. So let's see what that script looks like. So this is what the script looks like. Let me clean this up first and show you what the script looks like. So this creates an external data source. Then it creates an external table called ext_vehicle loans. And what it's actually doing is actually pulling all of that table metadata information from Oracle and creates a virtual table inside SQL Server. So let me go create that for you. And now if I go back to my Object Explorer, you will see that there are two new tables called external_branch and external_vehicle loans. And they have the keyword external mentioned, which means they're not tables residing inside SQL Server, but they're tables outside of SQL Server. And what I can do then is I can obfuscate the actual location of the table names using views, which is a very common development practice. So I'm actually creating a view for my vehicle loans and my branch on the SQL Server instance. So once I create that, what this gives me the ability to do is query the tables without having to know what the actual name of the table is. And I'll tell you the reason exactly why. I have this stored procedure which actually scores these loans. So what this actually does is it picks the loan ID, which is, in this case, I'm pretty bad at naming columns, which is why I'm calling it row ID. It takes in a few parameters, like the loan term, the original balance of the loan, the interest rate, and the remaining term months. And we created a model which predicts whether the loan is at a risk for charging off. And charging off is really bad because it's a default, and the banks have a risk if people don't pay their loans on time, which is a loss for them. And we're using this model, which is stored inside a SQL Server table, to predict each of the loans that are stored in the Oracle database. So I'm going to use SQL Server machine learning services to predict if a loan stored in an Oracle database is going to default or not. So let's see how that would play out. And because I have the capability of running the stored procedure from within SQL Server, I created a PowerShell. What it essentially does is it takes increments of 10,000 and it runs a scoring algorithm on top of all the external data set. And the reason why I say it's an external data set is because if you look at my stored procedure definition, it's actually querying the view. So now that I've queried the view, I've actually finished scoring the loans, about 40,000 loans in about 3 seconds. And now I can go and refresh the view, and it gives me a view of, I'm only scoring 40,000 loans of the 100,000 that I have there, and it was pretty quick. I'm pulling all of this data from an Oracle database using a SQL query. And generally, whenever we do these keynotes, because the Cowboys are having a bad time, I tend to make Bob feel nice. So the Dallas Cowboys are doing pretty well in giving out loans here. So what it's actually showing, if this was a business user from a credit union or a bank, it's actually showing that about 45.5 million loans given out by the Dallas Cowboys are at risk, and they need some kind of follow-up. And the rest of it looks pretty green. Well, Bob, Dallas Cowboys are at the top here.
We'll agree, huh?
So now, if I actually wanted to do this in SQL Server, let's say I imported all of that data into SQL Server, and I had those tables, which in the interest of time, I have those pre-created. Like I have tables which have 10 million loans in there, but I can now change my view to actually talk to a SQL Server table. So I can go and alter the view. In this case, I'm just dropping the view and recreating it, and I'm just pointing it to a SQL Server table. So I'm going to drop and recreate this. And now I can run the same scoring algorithm against the SQL Server instance. To the end user, again, there is no change because I'm just changing the underlying definition of the view, which is now talking to a SQL Server table, which is storing the data. And this came back pretty quick. And in this demo, my time calculation takes more time than the actual scoring, which is actually funny. Now I can go and hit refresh. And it's doing the exact same thing. It's pulling data from that same table, but this time the table is sitting on a SQL Server database. So from a scenario perspective, you can use SQL Server machine learning services to query an external data source and run an R or Python script to do predictive analytics. In this case, my data retrieval is really fast because the SQL Server table has a clustered column store index built on top of it, so the data retrieval happens to be really fast. If I wanted to cache the Oracle data over which I created the external table, I can pull that in and create a data mart using a column store index. And if I wanted to, I can even build a role-based access control on top of this because this is a SQL Server user that is accessing another table inside SQL Server. So any permissions or any kind of database roles that you assign to this particular user, they would be applicable for your big data tables or any other non-relational tables or any Oracle tables, as you saw in this example, inside my SQL Server instance. And that basically gives you the ability to now run two different scenarios. The first scenario, it's perfectly OK to have a virtual environment and a virtual table and all of this processing because SQL has inbuilt capability for ML services, which gives you the capability to do predictive analytics. You can run that scenario in production with SQL Server 2019. If you choose to move that data into SQL Server, you can do that as well. And if you're using views and you have security built on top of the views, your application, which is the key thing, your application goes through zero change. And there is a minimal downtime of changing the view definition to go use that capability. So with that, I'll switch back to my slide deck. And let's go back and talk some more about SQL Server. So now we've switched over to what the database engine does, the perf, security, and availability. And one of the things that we did not cover in the beginning of the talk was some housekeeping items. Because we have a lot to cover, we'll actually take questions at the end. We have some time reserved at the end of the session to take questions. And this slide deck will also be uploaded to the past website for you to download and look through the notes and some of the content that's in there with some helpful links. So going back to what Bob calls the meat and potatoes for SQL Server, perf, security, and availability. And this is a good question for Bob. Can anyone guess which was the first version of SQL Server that he worked on? Any guesses from the audience? 6.0. 4.2, OK.
OS 2 1.1.
Has anyone heard of that? Right? Quick show of hands.
Was anybody alive when that was around?
So with that, I'll let Bob talk about how we've progressed from that version to what we have 25 years after. Here you go, Bob.
Thanks, Amit. So Amit's right that performance, security, availability are the meat and potatoes. But I'll shamelessly say Connor Cunningham, our architect, he's the one that actually gave me, coined that term. You know, what Assad and Amit just talked about is really a huge part of what we're releasing in SQL 19, right? Big data clusters, data virtualization, because we believe from talking to customers, those are important innovations for us to move forward with this product. But you can't do those innovations if the heart of your platform doesn't do these three things. That's why we call it the meat and potatoes. And so when we plan a major release for SQL Server, we do think about innovation like big data clusters, but we always look at features that you need to enhance these three areas. So what we'd like to do now is Amit and myself are going to dive into actual features that are covering these three areas. Some of these we announced at Ignite in CTB 2.0, but also you're going to find a few things bulleted in here that you've not heard about that we're announcing today. So first, for performance, I'm actually going to go from the bottom up because I want to end talking about intelligent query processing. So if you were in the keynote this morning, you may have seen this kind of fun demo that Connor Cunningham and I did. I think you coined this phrase, right? It just runs faster for TempDB. I'm really being serious. Our goal is at some point in time, can this TempDB thing be something you don't worry about anymore? Can you just go build an app and not worry about how many files or whether there's latch contention going on in TempDB. And the team seriously talks about what is it going to take to do that. And what you saw in a demo this morning is not available in CTB 2.1, but it's something we're working on. We had a private build that we showed it on. So it's our intention before we release SQL 19, that functionality will be there. And it's not just one system table, it's any system table can we go optimize at that level. But again, the thinking is, as an app developer, no app changes, using TempDB, and it just runs as fast as you need. In the middle here, accelerating I/O performance with persistent memory and hybrid buffer pool are actually two really interesting areas of SQL Server where we're looking at hardware innovations and trying to stay ahead of them and making sure we're developing features that are part of that hardware innovation. So if you've not seen persistent memory or NVDIMM technology, the concept is that can I have computer hardware that is effectively at the speed of RAM but has persistent storage to it? And if SQL Server can recognize devices like that, we can do some very interesting things. We can bypass the I/O stack and actually copy data between this device to SQL Server in a way that's like a memory copy. Or, like this hybrid buffer pool concept, could we actually extend the buffer pool of SQL Server onto one of these devices? Therefore, from a buffer pool perspective, it doesn't even know that it's working on a persistent storage device. And hybrid buffer pool is something new to CTB 2.1, and we're actually having some sessions here at the conference where we're going to show you more and talk more about that. If you look at the second to the bottom thing, it says lightweight query profiling. We actually need to come up with a better name for that thing. We need a catchy name for lightweight query profiling. If you know our colleague Pedro Lopes, he is incredibly passionate about performance and about performance diagnostics. And so one of the things we've done in the past couple of releases is have the ability to turn on this lightweight query profiling with a trace flag or some options in SQL Server. And the goal is walk up to a SQL Server at any point in time and not just find out what queries are running, but see a query plan live in action as it's actually progressing on the server. Well, I'm proud to announce that in SQL 19, that's on by default now. We've been able to tune this in such a way that it doesn't cause any performance issues for you while you can run this, and I've got a demonstration to show that. But one of the key features that we're doing in SQL 19 is intelligent query processing. We announced functionality in SQL 17 called adaptive query processing. And in this tree that you see here of a suite of features, the ones that are not in bold represented adaptive query processing. And here's our thinking. The query processing team is one of the smartest folks that we have working on the engine. In fact, they talk a different language. I don't even understand what those guys, when they start speaking the language of query processing. But in a way, they're kind of chasing their tail, trying to fix problems in the QP for you based on plans that you present to us. Like anytime they make a small change, it actually kind of has a ripple effect to cause problems for other plans. So, and they still do that. They still, in some cases, need to make changes to the query processor to fix those problems. But instead, what they've tried to do to put more emphasis is, can they make the query processor adapt to query execution and make smarter decisions? Or when we're compiling queries, can we actually inject things into the plan that can then adapt to data coming in to the server? And you see this set of different features that are now shipping in SQL 19, and so we've kind of rebranded this Intelligent Query Processing family. For example, we introduced in SQL 17 the ability to do memory grant feedbacks for batch mode only, though, for column store. So when you have a query plan that's built that requires a memory grant, like a hash or a sort, after one execution or two executions, we could recognize this grant was incorrect, and then we can adjust ourselves on the fly, and in a way, fix your queries on the fly. And if you look at the range of these other options, it's a similar concept. One of the more interesting scenarios is table variable deferred compilation. So let me flip over to my demo machine and show you that in action. Okay, so I'm going to kick up this workload, and then I'm going to explain what I'm doing in the workload. Oops. Now, Amit, I need to convince you, I'm going to take that demo you did, we're going to put that on GitHub, man, that you just did for that table virtualization, but we're going to take the Cowboys part out of that. I think that's the one thing we're going to change. I don't want that in there. So, now I will tell you that the demos I'm showing you here are actually on GitHub today on my GitHub site at BobSQL. So don't worry about these. You can copy these down and do this yourself. So let me run and kick off this one workload, then explain what the workload's doing. So what's a common pattern for you? It's to build a stored procedure, and you want to use a table variable in the stored procedure. You might build a table variable. You might populate data from a permanent table, and then you want to join the table variable with another table in your database. It's a pattern we've seen over and over. Here's the problem. Table variables have an interesting aspect that the query processor assumes there's always only one row in that table. That can be quite a problem if you have a lot of rows in this table because we may make a poor choice, especially when we need to join data. So in this particular case, for the workload I've already kicked off, I'm running SQL Server in a environment where I'm running database compatibility at an older compat than 2019 because these intelligent query processing functionality is turned on by you, or you opt in by going to the latest compatibility level. So let me go ahead and kick off a version of this with the latest compatibility level. And when I run this, it's the same procedure. It's no changes. All I do is turn on the latest compat level. I'm going to come back and see what does my performance look like. And this is going to run actually faster than the first example. You notice this finishes in 13 seconds here, when it finished in, say, 35 seconds the first time around. Now, how can I see this difference in behavior? Many of you in the SQL community have started to learn to use a function called query store that we introduced in SQL 16. And it's really handy in this scenario for me. I turned on query store before I ran these demos, and I go to this report called top resource consuming queries. And I want to know something very interesting when I pick this one. Notice over here there are two circles. The upper circle represents the first execution with the old compat level. And if I hover over this, you're going to see that the average duration was like 4 seconds to run that query. And below, if I click on it, you can see what the plan looked like. Let me zoom in a little bit. In this particular case, we chose to do a nested loops join with the table variable, but we picked the table variable as the outer table. Well, why? Because the estimation was one row. Makes sense. It's only one row. We'll make it as the outer join, and we'll just loop through the inner join because it's only one row to do. This was a poor choice to make because actually there are 200,000 rows in this table variable. If you pick the lower circle, you can see the average duration is like 170 milliseconds. And if you click on it, you'll see something very interesting here. And let me zoom in. You're going to see, first of all, we still scan the table, but we now use a hash match join to do that because we know there are some 200,000 rows in that table. But notice something interesting on the left side. We're using something called an adaptive join operator as part of this plan. This is showing an example of combining multiple intelligent query processing features into one plan. And the reason we pick an adaptive join is if there is data less than, say, this 200,000 rows, a nested loop join could be the right decision to make. So in this particular case, we have the ability to adapt ourselves depending on the data that's actually in the table and actually modify the plan when it's querying. This is showing the power of intelligent query processing. You just go build your application, and the query processor makes smarter decisions and reacts to the data as the query is being executed. And again, query store is really nice to show you the examples for these. One of the things I want to show you about query store is the ability to query information inside the query store and what kind of power of metadata we provide with this. In this particular case, query store stores information called on query IDs. Those are unique executions of queries. When I run this particular join here, I get this piece of information. I can tell that the first plan that ran slow is at compat level 130, and its average duration was around 4 seconds. And the second query was compat 150, and its average duration was 190 milliseconds. The query store is amazing metadata performance for you. It actually stores, for a given plan, what was the compat level and what was even the version of SQL Server that you ran a query for. So imagine all the different types of comparisons you can do now for SQL Server based on what we store in Query Store. All right, let me show you one other demo here, and then I'm going to let Amit talk about some interesting functionalities we have to announce on security and availability. So I have to show this because my friend Pedro Lopes really worked so hard on this functionality. So I'm going to kick off this query. Nice, smart. And I'm going to go into Activity Monitor in SQL Server. And I'm going to pick this running query, and I'm going to pick Show Live Execution Plan. And many in the room are kind of wondering, what did you just do? Here's what I did. Because lightweight query profiling is on by default, I took a running query, and I'm poking into the live execution of the plan that's happening as it's going on the server. Pause for applause at this point. That is really amazing. Our goal is for you to be able to go anytime, anywhere to a SQL server and not just see the queries that are running, but see inside the execution of it. And you can look at this plan. There's a major problem here. This X indicates that this is a not good join that we're doing. Well, why? Because I actually joined to the same table twice. I made a mistake in my query execution. So I could go and actually could kill this and go easily fix the problem. If you didn't have this capability, how would you go figure out the problem? If you had Query Store on, you could see it after the fact. But what if this query takes an hour? How do you know whether you should kill it or not? Now we're giving you detailed diagnostics at a live running query at a very low level, at the operator level on a plan to diagnose anytime, anywhere your queries. So that's just a really good feel of some of the work we're doing in performance, and we have more to come as we continue down the release for CTP 2.1. So let me go back and turn it back over to Amit. And Amit, why don't you start talking to us about some of the great functionality we're doing in the area of security and availability.
Sure. Thank you, Bob. So the other two pillars that we covered when we started off this section was security and availability. And security continues to be a goal for Microsoft because all of our enterprise customers really care about security. You can't have a database that's storing secure data without having security out of the box. And some of these capabilities that we talked about at Ignite, and I'm going to quickly cover those, was always encrypted with secure enclaves. So enclave, think of the enclave as a secure computational area on your chipset. And today you have this capability to do separation of duties with always encrypted, where the application holds the key to encrypt and decrypt your data, and the data, encrypted data, is stored in SQL Server. That's great, but every time you have to do some mass changes or have to do any kind of decryption or encryption of the whole data set, the data has to move through the application, which is not sitting on the same server. Typically, most mission-critical applications don't host the application or the application middle tier and the database on the same server. Now, with the ability of using enclaves with SQL Server, you have the capability to bring the computation, the secure computation, closer to your data without actually compromising the security. So you'll have the ability to use APIs that SQL Server will leverage on the chipset to do encryption and decryption. And if you've used BitLocker on your laptops, that only encrypts data at rest and ensures that if someone walks off with your hard disk, your data is not compromised. Think of a similar concept, but for code execution. Now, the encryption and decryption code is actually executing inside a secure component of the chipset, and you don't really have to worry about whether the DBA administrator or any other admin on the system can access the key to decrypt the data or not. The next thing I wanted to quickly mention was data classification. When Microsoft implemented GDPR compliance, a lot of our customers were also doing the same thing. And one of the key things that came up was how do you actually handle deletion requests, or how do you go actually audit the data that you have in your system, especially if you have multiple tables and multiple databases which store, let's say, PI information like credit card, social security numbers, or even email addresses. Now, let's say more than one table and more than one database has this information. Wouldn't it be really cool if you had like an English label which you attach to a column in multiple databases saying this is PII data, and then be able to audit it? That's the capability we're giving to you in SQL Server 2019. You'd be able to attach English labels to columns within a SQL Server table, and then you'd be able to use the SQL Server audit functionality to essentially audit a label. So you can audit whether people are accessing data tagged with that label. You'll be able to audit whether they're reading it, writing into it, or doing anything which touches any data associated with that tagged column. And all of these tags will be available in the SQL Server metadata table. So if you actually do a select from, let's say, sys.columns, you would see that metadata information in there. One of the new things that we are announcing with in this session is the ability for SQL Server to do static data masking. It's not there in SQL Server CDP 2.1, but this is something that will be available in the future. So we announced dynamic data masking in a previous release, where you could actually dynamically mask the output to the end user. But if they had admin access, they could still go in and see the data because the data at rest is not masked. Now you can persist that mask with static data masking, and that's really neat because if you have to actually take your production database and give it off to your developers, you need the ability to mask any sensitive information and give it to your devs because your devs actually need real data or at least a real set of statistical data to create performant queries. Otherwise, you end up in this situation where, hey, everything works well in test, but the moment I turn it on in production, things actually go south. So moving on from security, let's talk about availability. These are also things that were available in SQL Server CDP 2.0. One of the really interesting things that we talked about at Ignite was the ability for SQL Server to now redirect connections which are read-write in nature. So when we announced SQL Server 2012, we added the capability of SQL Server availability groups to use a virtual name called the listener. So if your application was connecting using the listener, if it failed over, your application basically could use the new primary replica. The challenge that happened was no one really developed applications in the beginning that were running during the year 2012. They were developed on previous versions of SQL Server where you didn't have the concept of a listener. And some of these connection strings were hard-coded. Some of these machine names could not be changed. Some of these application codes could not be changed. So what do you do in those scenarios where you cannot really change the application name and the application name stays constant? So you have an availability group, but you cannot use a listener because let's say you're using an older driver, an older application, and you don't have the ability to change code. So we added a capability for a connection, if made to a secondary replica with read-write intent, to be redirected back to the primary replica. So that is a capability which allows you to use your legacy applications in an availability group configuration and still leverage high availability features of SQL Server without having to make an app change. The other thing which was pretty big and something that I'm personally very excited about was the ability for SQL Server to run on Kubernetes, but natively using an availability group operator. So what you see in the picture there, the architecture diagram basically shows how SQL Server availability groups will be implemented on a Kubernetes cluster. And this is as simple as running a Kubernetes command to deploy the availability group, set up the listener, and then have it monitor the SQL Server instance for failover. So if a failure happens, the primary would switch over to the next available secondary, and all your connections would be redirected to that. Now, I have two new things to talk about. How many of you have experienced, a quick show of hands, a slow recovery situation after your SQL Server has restarted? Quite a few. So if you were at the keynote, Rohan talked about this. We're going to get accelerated database recovery on the on-premise instance that you have today. Once you upgrade that to SQL Server 2019, this will show up in a future CDP where you will be able to do, because we're using a persisted version store for maintaining our log records, your recovery is going to be constant time. In simple words, it's instantaneous recovery for the most part. So as Lindsay was showing her demo during the keynote, she actually restarted an instance which is getting a lot of inserts, and the database came online immediately, and that is what would be available for SQL Server 2019. So think of an availability group and you have an unplanned failover during peak business hours, your database just comes online. It's just not the instance. And how many of you have actually wished that SQL Server availability groups could actually do other things other than just the database, like logins, jobs? Do I need to say more?
Yeah.
So we don't have this in CDP 2.1, but in future CDP release, we will support putting your master and MSDB database inside an availability group. And that would give you the ability to protect the whole instance without having to change your logins, your job scripts every time a failover happens. I can see a lot of smiles in the audience. Thank you very much. So let's move over to see how we are actually changing the game when it comes to developing for SQL Server. So Bob, you've worked on SQL Server for 25 years. Why didn't you tell us what the experience was back in the day?
Visual Basic, Novell Networks, DB library, does that all sound familiar? Maybe we started with OBC, but yeah. Pretty basic T-SQL, that was. Client server.
Isn't that coming a full circle now? And if someone didn't know, Bob's written a book on SQL Server and Linux, and Bob has spent 25 years doing SQL Server and Windows.
Yeah,
so
it's kind of ironic, isn't it? Yes.
Isn't it coming like a full circle?
It is, because I was a Linux developer, actually, before when I joined Microsoft, for 6 or 7 years before I joined. So it is kind of coming full circle, yeah.
I can't think of a better person to walk you through the next section of our presentation.
Thanks, Amit. So I have a passion for developers, because I used to be one. And I don't develop now for our actual product, but I certainly work with our team. And what Amit showed up there, by the way, for AGs for system databases, accelerated data recovery, we're very serious about trying to get these releases in as soon as we possible into a CTP. But the team had worked really, really hard to get this to a state where we felt comfortable announcing it to you here at the conference. If you think about things we're doing for developers, certainly if you've looked at graph databases in SQL 17, it's a very new, interesting paradigm for you now as a developer to not have to actually create massive queries to go munge a relational table into what looks like a graph model. And so naturally, we've added T-SQL enhancements to make that easier for you. And we continue down that path. There's some new enhancements both in CTP 2.0 and 2.1 to help that graph journey. A very exciting thing we've announced is now UTF-8 collation support. And in CTP 2.1, yeah, there you go. Very exciting stuff. And it's embedded into the setup experience in CTP 2.1. So you have Unicode data now. Start using that collation and immediately recoup amazing benefits now in the amount of storage you store for Unicode data. Machine learning services has been enhanced on Windows to support failover clustering. That also now works in Linux. But what I'm excited to talk to you about that we announced in CTP 2.0 is Java. So Amit showed a demo with machine learning models with R, and then we announced Python in 2017. And you can see in the diagram here to your right, we took the ability to run those languages and extend it to Java classes now in Java. And that works both on Windows and Linux. And the amazing thing about the technology, if you've not seen this before and you're a little nervous to yourself, like, I am no way am I letting a Java program running on my SQL server, consider our architecture. Your R scripts, your Python scripts, your Java classes don't run in the SQL Server process like they do with, say, CLR or extended procedures. We actually use a very clever technology called a launchpad process, which runs outside SQL Server in a low privilege state, and it actually launches out your different programs. When you saw Amit run sp execute external script R, it's actually running a separate R process to host that R program. And so it runs low privileged, but here's the thing you're going to love. It's tied into Resource Governor. So you now can take Resource Governor and control memory, processor, and affinity against any of those programs running outside the SQL Server process space. But it lives and runs on the same computer as SQL Server, so we can do this direct pipeline between what we call a satellite program and the native SQL Server, and that's how we achieve performance of exchanging data back and forth with these processes. So I think Java brings a whole new class of opportunities for Microsoft and for you. If you're somebody that uses an Oracle system, say Java procedures, now consider that Java capabilities are working and embedded and extending the T-SQL language. Think of this model as extending the capabilities of T-SQL. If there's a T-SQL function or something that you don't have, now perhaps you can extend it by using something like Java. So let's just take for a minute here and look at an example of what that looks like. You saw a little bit in the keynote. Assad and Nelly were on stage today, and I think they did use a Java example for that. But you might not have caught exactly what they were doing. So in this particular case, and Nelly's the one that gave me this example. In fact, I had to ask her what an n-gram was. I'm just a poor little programmer. What's an n-gram? An n-gram involves natural language processing. And so we don't have a T-SQL function called n-gram, right? But if you wanted to do n-gram processing on data in SQL Server, you could take Visual Studio Code and build out a Java class. This is actually in our documentation. And then in SQL Server, just like you were seeing the example from Assad and Ellie this morning, or in Amit's example with R, here is me running that Java class, but the key is I'm actually taking data from a query in SQL Server, and then the Java program is able to talk to SQL directly to iterate over those rows, and then produce back a result set based on that data. So by installing my Java classes and compile them, I can just run this query and instantly get back the results that you see here are the n-gram results from running that query. So again, think about the possibilities now. If there's T-SQL functionality that you don't get supported, but you have a Java programmer or Java's a language for you that you like, you could write Java classes now and interact with SQL in a new and interesting way. And so I've talked to Nellie a little bit about this. We want to start producing more examples for you. In fact, we were just talking about doing regular expressions as an example, and I think Nellie may be showing that off here at the conference. She's been working to see that kind of example. So that's just a flavor of what we're doing for developers to extend T-SQL and give you new types of capabilities, still taking advantage of your skills in the T-SQL language. Now, Amit just said that I've been working on this thing called Linux for a while. It's been a passion of mine over the last year. And one of the things that customers have told us is, I love what you've done in SQL on Linux. You've told us about the architecture. It's the same core engine. But there are features on the edge of the engine that you don't have, such as replication, distributed transactions, and machine learning. All of those capabilities exist now in SQL 19. So if you need transactional replication, distributed transactions, or machine learning, they are now in SQL Server on Linux. And we know that customers that have done AD authentication have sometimes struggled with that configuration, so we now have open LDAP provider support with products like Centrify to make that experience even better. We're doubling down on containers. The big data cluster environment you saw is all based on Kubernetes and containers. The availability groups that Amit just talked is all based on Kubernetes and containers. And so we have several things that we've done in this release. Number one, following kind of a standard here now at Microsoft, all of our container images will be stored in something called the Microsoft Container Registry. It's kind of a known standard location, but will still be syndicated on things like Docker Hub and the Red Hat Container Catalog. And speaking of Red Hat, so far our Docker containers have just been Ubuntu-based, and we now support actual official Red Hat container images. If you'd like to drill in more into what's going on, Vin Yu and I have a session tomorrow afternoon where we'll go into all the different functionality and features of what's new for SQL Server, Linux, and containers. So I hope you've kind of noticed that maybe in the keynote this morning or some of the things we've talked about, we don't just ignore the feedback you give us. And so if you think about some things we've done as far as column store to make sure they're included in different DBCC commands or diagnostics, we've done that. But take a look at what you see on your right-hand side. Did you guys catch this from the keynote this morning? This old error message has now become this error message, finally. Yeah. So pretty excited that we've finally been able to release this for you. And here's a great story for you. This has been backported already. This is now in SQL 17, and it's going to be backported into SQL 16 as well. So in all those releases, you will have that message. And then maybe you caught on stage this morning when I did a little TempDB demo, this little SQL script. So no longer, and I love my friend Paul Randall, but no longer do you have to have Paul Randall decode a page for you. Actually, you can take a built-in T-SQL function now and crack a page header. We will give you all the fields in a page header for you to look at. Some people love doing that just because they like doing internal fun stuff. But the scenario I showed this morning was pretty interesting, right? If you go into one of our DMVs and you're waiting on like a page latch, but you have no idea what object that belongs to, you can now run a query like the following, and you can see exactly what's the database, what's the file, and what object this has belonged to. And you saw in my demo that for TempDB, that was pretty important to be able to know what the scenario looked like. So that's some interesting thing. We have more. There are more on this list that we have not been able to talk to you yet that the team is currently working on. And I'm telling you, every single thing you see here was based on an actual voted item and feedback as a community you've given us. So I'm going to let Assad come up here in a second and talk about a little bit the future, what's past SQL 19. We're doing really good on time. Let me make a comment for a lot of you in the audience here that know me and know the SQL community about what we announced about Azure Data Studio and Management Studio. So there was a lot of discussion on the team, like what should we call this SQL Operations Studio tool? That was the name of it during the preview. And we landed on Azure Data Studio for a couple of reasons. Number one, it's our intention, and we're trying to get better at it, that the word Azure is not cloud only. That Azure is a hybrid name. In fact, right guys, we work for an organization called Azure. Literally, Rohan Kumar, our boss, is in charge of the Azure data team, and SQL Server is under that umbrella. So it's not our intention to get rid of SQL Server or just stay in the cloud. It's a hybrid story of your private cloud and a public cloud. So that's one of the reasons we picked the name Azure. And why is that? Because Azure Data Studio will allow you to connect and interact with data both on your private cloud assets and your public cloud assets, and even more than just relational. As you saw, he talked about a little bit in the keynote about the intention of this tool to be something to go across different types of data sources. Think of this as your data exploration tool, or to do things like manage things like big data clusters, new and exciting things. But I have personal testament and experience to tell you that Management Studio is alive and well. We have a new version called in preview right now, Management Studio 18.0. It only runs on Windows, and that's our intention to keep it there. But we will continue to make that the best database administration experience for you with the SQL Server product. One of the comments about Azure Data Studio that is interesting to our community is that it's open source and cross-platform. If you're a MacBook user and you're tired of running virtualization software to run basic SQL Server queries, this is a native Mac application and a Linux application because it's based on Visual Studio Code. So with that, I would kind of like to end today to let Assad come back up here and talk about his vision for where we're headed past what we're doing here in SQL 19 CTPs, and then we'll conclude our session today. Assad?
Thank you, Bob. So I will just spend 5 minutes on this, talking about like what we are thinking from the future perspective, and then I want to make sure that we have time for Q&A. So broadly speaking, I will say that there are 2 or 3 areas where we are investing a lot. Like basically, the first line says about SQL Server on Edge. We are very serious to make sure that we can bring SQL on every platform and every chipset we can. And the goal over here is that how can we enable the people who are already familiar with SQL, are building applications, whether you are a customer, whether you are an ISV, whether you are an OEM, how we can take you forward as people go and start to invest in other areas where it requires you to run database systems on other type of platforms. The second thing is, obviously, we will continue to go and finish anything we go and start. As Bob mentioned, like basically, now we are very proud that in SQL 2019, we have caught up all the delta that we have between Windows and Linux. So similarly, with big data, if we are starting on that journey, we will make sure that we deliver a very cohesive story in 2019, but we continue to invest. So basically, people who are taking a bet on SQL Server for their big data projects, they continue to see the innovation. Because in the industry out there, whether it's open source or proprietary, the innovation will continue to come. So if we are deciding to go in the big data space, we will make sure that this stays as the #1 platform for all scenarios in the big data space. The other thing which I want to talk a little bit is that as we worked on the big data cluster form factor, and Amit showed that, the complicated architecture of the cluster, one thing we realized is that we have to build a control plane that is part of the cluster that helps you easily manage all the assets that we are shipping as part of that cluster. And as we were building and designing that thing, the thing which we had the learning from was we are doing a very similar thing in the cloud. In the cloud, when we go and ask for a database, or whether you ask for an MI instance or you ask for a big data, you go and talk to a control plane, and the control plane manages it for you in terms of how it allocates the right resources, how it can go and shrink and grow your cluster sizes, and how it manages your resources over there and provide you the HA and DR. We took a lot of that control plane code and actually are shipping as part of the SQL 2019 big data cluster. So if you go and think from that perspective, the intent we have is that how can we provide a fully managed platform, a fully managed data platform outside of Azure for our customers. That is very critical for us from our hybrid story, because if we can go and deliver that successfully, what that means is that if you are running your SQL Server in your own database, in your own data center, then you can take the advantage of the same things that you get when you are in Azure. So think about all the workflows, the FSM, which do the backup for you, which gives you the HA over there, like you get automatically over there. Like we will get to some point in 2019, but this is a journey for us. We will ensure that we give you a fully managed platform outside of Azure where that you can go and run anywhere. That gives you the same scalability, manageability, ease of use, and it gives you the hybrid scenario, because the day you decide, oh, I want to go and now take the same workload and run in the cloud, you will see the same experience. And even if you are in the hybrid, you will start to see that thing. So, and other than that, basically, that as Bob mentioned, meat and potato, like basically we will continue to invest in performance, we will continue to invest in security and availability, and make sure that people can run these systems in their mission-critical applications.
Assad, it's true. It's our intention that these CTPs will come out very regularly
Yep.
until we ship the product.
Yeah.
And the running joke that I tell Assad is like, Assad, like, when are we going to find, like, when is it going to release in SQL 19? Like, when is that going to happen? And the answer back is that we will not become the first product to miss a name at Microsoft. So, yeah, everybody's like, oh, groan, aren't you going to give away the date? So no, I mean, to really be seriously, we haven't really picked a date yet, to be honest with you, because we want to make sure that what we're doing, we get your feedback for it, and we still have some innovation that we want to put into the release. So it will ship next year in the calendar year, but we don't have an actual date reserved yet. But we will make the year, that's for sure.
Yeah.
Or else we'll lose our jobs, right?
Yeah, that's right.
Hey, man, I think it's been a great event. I hope you've enjoyed it here. We're going to have time for a few questions. I think Amit's going to run around with a mic, I think, maybe to take your questions here. Here's some information for you. Feel free to take, I'll leave this up. You can take a photo of this. This is where to get more information about SQL Server 19. At this session at PASS, we have so much stuff going on. In fact, I couldn't list all the sessions on the slide. I just picked 3 of them that are happening today, Thursday, and Friday. One, if you want to dive more into the big data clusters, Travis Wright and his team are going to be this afternoon talking about that. If you want to know more about query performance insights, Thursday, Pedro Lopes and Joe Sack will be dealing more into that. And then sorry, this is actually listed incorrectly on here. This should say inside SQL Server containers, not what's new. So on Friday, if you want one of those internal talks that I'm kind of famous for doing, I'm going to dive into the inside story of how containers work with SQL Server under the covers. That's Friday at 2 o'clock. And then shameless plug, anytime you do a talk and you write a book, you get to plug it, right? So I have actually published a book. It's available at the bookstore. You might want to take a look at it. I wrote the book specifically for 2 people. One, a SQL Server user that doesn't know Linux, and then somebody who doesn't know SQL Server. You'll find sprinkled throughout there some interesting stories over 25 years of the SQL Server product. So I hope you'll get an opportunity to take that book. And if you find me the event, I'm happy to sign it for you, which is a new thing for me because I've never done signings before. So with that, I know you guys probably, a lot of you may want to take off and go to your next session, but we will stay here for the next, as long as we need to, and answer questions that you have. And Amit has a mic to walk around if you have a question.
And also for the feature.
Thank you.
Thanks very much.
Thank you.
So, for the feature.